Hey there guys, running a bit of an experiment here with an OCR past paper. At the moment I have no OCR content. If you want to see more, please let me know down below in the comments and give this video a like. So, seems like OCR like to do things differently. Paper 1 is a calculate paper. We're on foundation. I'm going to try and get it done all in one video. So let's crack on. Okay, question 1. First of all, I want you to measure this angle. So hopefully you're alright using a protractor. Make sure you can get 44 degrees. Okay, then part 2 wants us to write down the mathematical name of this type of angle. It's less than 90, so it's an acute angle. Part B wants us to choose a word from the list to describe these lines. So the little arrows on them mean that they are parallel. So these are parallel lines. Good times. Question 2a, we want to use either inequality symbols or the equal sign to make these statements true. So for part 1, we've got two numbers, 17.6 and 17.06. So here, 17.6 is bigger than 17.06. So we want to use the inequality sign that way around. Okay, then part 2, 0.9 and 45 fiftieths. So if you put 45 fiftieths into your calculator and press equals, it will give you 9 tenths. So 9 tenths is 0.9. So here we want an equal sign because the numbers are equal. Okay, then for part B, we want to round 184,329 to the nearest 100. So the hundreds are in that place. So we got 329. So this is going to round down to 184,300. Cool. Write 5/8 as a decimal. Stick that in your calculator, press the SD button, and that will give you 0.625. For question 3, we've got a list of numbers, times. Okay, part A wants us to write down the even number. So that is going to be 42. Part B wants the square number. So that's going to be 81. 81 is 9 times 9, so it's square. And then part C wants the prime number, all the prime numbers. So that means there's going to be more than one. Okay, so 11 is prime. Remember, what we're looking for is a number that nothing goes into except for 1 and itself. So 27 isn't prime, 3 and 9 go into that. 81 is square, so that's not prime. 21 has 3 times 7. 41 though is prime. Then 42 is even, so that's not prime. 23 is prime. And that's our last one. 39 has factors 3 and 13. 45 has 5 and 9. All done. Good times. Okay, question 4. Karen makes 40 cakes. She gives 1/5 of the cakes to Andrew. She gives 10% of the 40 cakes to Chris. What fraction of the 40 cakes does she have left? So we need to work out how many she's given away. So your calculator can do this. 1/5 of 40 on your calculator is 1/5 times 40, which gives us 8. 10% of 40 is 4. So altogether, she's given away 8 plus 4 cakes, which is 12. So she has left 40 minus 12, which is 28. So she has 28 cakes left. As a fraction, that's 28 40ths. Doesn't ask for it in its simplest form, so that's a fine answer. Okay, question 5, we got some coordinate fun. So we got points P and Q on the grid. Part 1 of question A asks us to write down the coordinates of point P. So remember, coordinates go along the corridor and up the stairs. So our x coordinate is 4, our y coordinate is 3. So it's 4, 3. Part 2 wants us to write down the coordinates of Q. So Q has an x coordinate of -2 and a y coordinate of -1. So it's -2, -1. Cool. Part B wants us to plot point R at 3 -2. So we go across by 3 and down by 2, which puts point R there. Okay, then part C wants us to draw the line y equals 3. So y equals 3 is a horizontal line that goes across from the y-axis, from the point where y equals 3. So use a ruler when you're doing this. Roughly though, our line y equals 3 goes across like that. Make sure it goes all the way through the grid and that you use a ruler. Okay, question 6 wants us to work out 17% of 54, giving our answer to 1 decimal place. So don't faff around doing this without a calculator, because it's a calculator paper. So the way that I've always done this is to use decimal equivalents. So 17% is the same as 0.17, and you multiply that by the number, so times 54, and you will get 9.18, which to 1 decimal place is 9.2. You can also use the percentage button. If you did it like that, you would want to do 17% times 54, and then it's the same from there. Okay, question the 7a wants us to simplify 7t minus 6u add 5t minus 4u. So to simplify means to write in as fewer terms as possible. So combine the t's, combine the u's. So we've got 7t add 5t. So that's going to give us 12t. Then we got minus 6u minus 4u. So that's going to give us minus 10u. Good, times part B wants us to factorize 5v plus 20w. So factorize means to put into brackets. So here we have a common factor of 5. So we could write this as 5 brackets v plus 4w. Cool. And then the C wants us to solve by factorising x squared plus 10x plus 21 is equal to 0. So this is a quadratic. So to factorise these, we need 2 pairs of brackets. Each of them has an x at the start. So what that does, if we were to expand that back out, that would now get us our x squared term. Now what we need, inside of each bracket, we need 2 numbers that add together to 10 and multiply to 21. So that's going to be 3 and 7. Now that's it factorised. To get our solutions, we set each bracket equal to 0 and solve for x. So the first one, x plus 3 is equal to 0. Take away the 3, so x equals minus 3. That's one of our answers. Or x plus 7 is equal to 0. So x equals minus 7 is our other answer. Okay, question 8, we got a recipe question. So it's for apple crumble, and this recipe serves 6 people. So we got 550 grams of apples, 200 grams of sugar, 120 grams of flour, 30 grams of butter. So part A, Susumu, sorry if I'm mispronouncing, makes apple crumble to serve 12 people. How much flour should he use? So 12 people is going to be double this recipe because it's for 6 people. We want to know how much flour he should use. So we're going to do 2 times 120 grams, which is 240 grams. Good times. Natalie makes apple crumble for 2 people. How much butter should she use? So this time we only want 2 people, so we're going to divide the recipe amount by 3. So 30 grams divided by 3 is 10 grams. Okay, then for part C, Abina has 1.3 kilograms of apples and plenty of the other ingredients. Can she make apple crumble for 15 people? We must show how we get our answer. So, first of all, 1.3 kilograms, multiply that by 1,000, and we get 1,300 grams. So, for 15 people, we need to know what we would need to multiply the ingredients of the recipe for 6 people by. So, if we did 15 divided by 6, we get 2.5. So that means for 15 people, we multiply the recipe for 6 people by 2.5. So, we want to know, basically, if she's going to have enough apples. So we're going to do 550 times 2.5. So 550 times 2.5, that's going to give us 1,375 grams. So she doesn't have enough apples, so the answer is no. Not enough apples. Cool. To 9, so George records the scorers of 120 goals scored. Sorry. He started to draw a pie chart. So we got Simon here, who has 1/4 of the pie chart. Part A asks us, how many goals did Simon score? So that is 120 divided by 4, which gives us 30. So Simon scored 30 goals. Now the table shows the other players who scored goals, and we want to complete the table. So what we need to work out first of all is how many degrees one goal is worth. So we know the angle around a whole circle is 360 degrees. In this pie chart there are 120 goals. So to work out how many degrees one goal is worth, we do 360 divided by 120, which gives us 3. So every goal scored is worth 3 degrees. So for Harry, who scored 5 goals, his angle is going to be 5 times 3, which is 15. To go backwards from the angle to the number of goals scored for Obi, really, I love the names they put in. We do 72 divided by 3, which is going to give us 24. And then for the last one, we either need to work out the number of goals left or the angles left. So the goals are smaller numbers. Don't forget, Simon already has 30 goals. So if we add together 30 and 48, that gives us 78. Add 5 gives us 83. Add 24 gives us 117. So, sorry, 107. So there are 13 goals left for this last person, and the angle there is going to be 3 times 13, which is 39. Okay, then the last part wants us to complete the pie chart, so I'll do that and show you what we should get. Okay, so your completed pie chart should look something like this. Don't forget to label the sectors, otherwise it doesn't mean anything. So here I've been a bit lazy and just used the first letter of the names. You can write in the whole name if you want to. Question 10. The pass mark for a test is 86%. Steve scores 52 out of 61. Does he pass the test? Explain our answer. So the way that I'm going to do this is find what percentage 52 is of 61. So if you do 52 divided by 61, you get 0.852, which carries on, and that's enough for us. If we then multiply that by 100, that is 85.2%. So the answer is no. Okay, question 11. 320 people go on a coach trip. Each coach holds 53 people. Gary says 6 coaches are needed. Is Gary correct? So let's see if 6 coaches would be enough. So 6 times 53 is only 318, which isn't enough. So no, is not correct. 7 are needed. Okay, question 12. Trish and Mark both cycled the same distance. Trish completed the distance in 2 hours at average speed of 16 miles per hour. Mark completed the distance in 4 hours, and we want to work out his average speed. So this is speed, distance, time. So remember, speed is distance divided by time. So what we can do here, using Trish's data, where we know the time and the speed, we can work out the distance. So distance is speed times time. So using Trish's data, the distance is 2 times 16, which is 32 miles. So the distance is 32 miles. Mark took 4 hours, so Mark's speed is 32 divided by 4, which is 8 miles per hour. Okay, 13a. So the ratio 20 minutes to 1 hour can be written in the form 1 to n, and we want to find the value of n. So here, when the ratio is given to us originally, the two things are in different units. So we're going to want to turn 1 hour into minutes. So 1 hour is 60 minutes. So this is 20 to 60. There's a common factor there of 20, so it goes down to 1, 2, 3. So n is 3. Okay, part B. The scale on a map is 1 to 25,000. How many kilometers on the ground is represented by 6 centimeters? So this is saying 1 centimeter represents 25,000 real centimeters. So let's make 25,000 centimeters a bit nicer. So 25,000 centimeters, if we divide that by 100, we get 250 meters. So 1 centimeter represents 250 meters. We want to know how many kilometers 6 centimeters represents. So if we multiply both sides of that by 6 centimeters is 6 times 250 meters, which is 1,500 meters. So that in kilometers is 1.5 kilometers. Good times. Okay, part C. Kiwi and Peter share some sweets in the ratio 6 to 7. We want to know what fraction of the sweets Kiwi gets. So, how many parts to this ratio are there? 6 on the left, 7 on the right. So there's 13 parts. Kiwi gets 6 of those parts. So it's 6/13. Okay, question 14. So for part A, we want to write 543,000 in standard form. So remember, standard form is always a single digit. So here it's going to be 5 point anything after the decimal. So here we're going to want 4, 3, and then it's times 10 to a certain power. So to work out this power here, we want to know how many places would the decimal point here need to move to the right to get us back to 543,000. So we're going to go 1, 2, 3, 4, 5. So it's 5.43 times 10 to the power of 5. Next, we want to write 6.3 times 10 to the minus 2 as an ordinary number. So a negative power makes your decimal place go to the left. So here, our decimal point is going to go to the left by 2 places. So this is going to be 0.063. Okay, then for part C, Piers is given this question. So he wants to work out 61,000 times 4,000, giving his answer in standard form. So he got this answer here, 24.4 times 10 to the power of 7. Now we're asked, is Piers correct? And then to explain our answer. So we don't actually need to work out the answer here, we just need to spot that Piers is wrong. So it's the 24 that tells us he is definitely wrong. Remember, he was asked to give his answer in standard form. So 24 is not a single digit. So we could say whether or not this is right, the answer is not in standard form. So we can just say no, not in standard form. Okay, question 15. So probably quite a tricky one. I know this is the type of question people don't like. So Mr. and Mrs. Thomas buy tickets for themselves and their 4 children. The cost of an adult ticket is £7 more than the cost of a child ticket. The cost of all 6 tickets is £86. We want to work out the cost of an adult ticket. So let's first of all turn all of these words into maths. So we are buying 2 adult tickets and 4 child tickets. Now we know that the total cost of all of that is 86. Now we know that an adult ticket is £7 more than a child ticket. So algebraically we can say A equals C plus 7. So mathematically that is saying A is 7 more than C. It's the cost of C plus another 7 on top. Now we want to work out the cost of an adult ticket. So what we're actually going to do, we're going to write what C is in terms of A. So if A is C plus 7, we could say A minus 7 is equal to C. So a child ticket is an adult ticket minus £7. So what we're going to do now is substitute this into our first equation. So where there's a C, we're going to write it as A minus 7. So let's change colour. So we can now write our equation as 2A add, well, we had 4 child tickets, but we know a child ticket is A minus 7. So we can write this as 4 lots of A minus 7. And that is all equal to 86. Now we want to expand and simplify the left hand side. So we've got 2A add 4A minus 28 is equal to 86. So 2A add 4A gives us 6A minus 28 is equal to 86. If we add 28 to both sides, we get 6A is equal to 114. And then finally, if we divide by 6, A is equal to 19. Jobs again. Okay, question 16, we got some loci and construction here. So the scale diagram shows the location of town A and town B. Ignore that for a second. So we're told Lucy's house is nearer to town A than to town B, and it's exactly 50 miles from town B. We want to show the possible locations of Lucy's house, showing all of our construction lines. So we're going to take care of the first statement first of all. So Lucy's house is nearer to town A than to town B. So I've already done this bit. If you are told something is closer to one point than another point, what we need to construct is the perpendicular bisector of the straight line that joins these 2 points together, which is exactly what I've done here. So let me talk you through. So first of all, I drew the straight line that connects point A and point B. You don't need to do this, but I think it makes things a bit nicer. Then what you want to do is mark on the midpoint of that line. So that's my black X there, my black cross. So what we need to do now is get your compass out and open it so that it's definitely wider than that midpoint when you have the point on either A or B. So then what we want to do is draw an arc. So say that I've got the point of my compass down on point A. We are then drawing the top green arc, which is just up and to the right of my black cross. So make sure you get a nice big arc in there. Then, very importantly, without changing the size of the compass, put the point up on point B and draw another arc, again using the exact same width with your compass, so don't change the compass at all. Now what we're interested in is this point up here and this point down here where those two green arcs intersect. So we then join those 2 points together with a ruler. So what this gives us here, my red line is a perpendicular bisector of the line that connects points A and B. Now, anywhere on that line is exactly the same distance from point A as it is from point B. Anything left and below the line is closer to town A. Anything to the right and above the line is closer to town B. So at the moment, we were told that Lucy's house is nearer to town A than town B. At the moment, we know Lucy's house is to the left and below that red line. Okay, so now for the second bit, we're told Lucy's house is exactly 50 miles from town B. So what we need to do now is use this scale. So we'll use orange for this bit. So 1 centimetre represents 10 miles. So 5 centimetres is going to represent 50 miles. So what you need to do now is set your compass to 5 centimetres, put the point of it on town B and draw an arc with a radius of 5 centimetres. And what's going to happen, so I'm not going to do this accurately, but what will happen is you will get an arc something like that. Now anywhere on that orange arc is exactly 50 miles from town B. So Lucy can live anywhere that is to the left and below the red line, but on the orange arc. So Lucy can live anywhere there, but it has to be on the orange arc and to the left and below the red line. Hope that makes sense. Okay, question 17. At the start of 2014, Priya's house was valued £240,000. Every year it increased in value by 5%. We want to work out the value of our house at the start of 2017. So this is percentage increase or sort of compound interest type stuff. So how many years are we dealing with? 2014 to 2017 is 3 years. So it's 3 years, and we also need to convert 5% into a decimal. So 5% is 0.05. So we want to do 240,000 times 1.05. That gives us our 5% increase to the power 3, because it's over 3 years. Now that will give us £277,830. Okay, question 18a. We want to write 490 as the product of its prime factors. Now, your calculator can do this. If you don't know how, I'm putting a link down below in the description to my video showing you how to do that. For now though, we'll do it without, because it's good practice. So, 490 we could write as 10 times 49. Now neither one of those is prime. 10 though is 2 times 5, they're both prime, and 49 is 7 times 7. So we could write this as 2 times 5 times 7 times 7, which we could sharpen up to 2 times 5 times 7 squared. And for part B, we're told buses to Ayton leave the station every 25 minutes, and buses to Bleaford leave every 40 minutes. Buses to both places leave at 9 AM. We want to know what is the next time buses to both places leave together. So we need to find the smallest number, the lowest common multiple of 25 and 40. So the first number, 25 and 40, both go into. So the easiest way to do this is just to list some of their multiples. So 25 goes 25, 50, 75, 100, 125, 150, 175, 200, we might have enough there, let's see, 40s, then go 40, 80, so remember what we're looking for here is a number that 40 goes into, that 25 also goes into. So then we got 120, 160, 200. Winner, winner, chicken dinner. So 200 minutes later is the next, 200 minutes later is the next time buses are going to leave together. We need to work out when that time is. So 200 minutes, how many hours is in that? 60, 120, 180. So this is 3 hours, 20 minutes. So 3 hours and 20 minutes later than 9 AM is 12:20 PM. Okay, question 19. So Kirsty either travels by bus or walks when she goes to the shops. The probability that she catches the bus to the shops is 0.3. The probability she catches the bus from the shops is 0.8. So we got this tree diagram here. Part A asks us to complete it. So for the first branch, remember that probability has to add together to 1. So to the shops, if the probability she gets the bus is 0.3, the probability that she walks is 0.7. Then we're told from the shops, the probability she gets the bus is 0.8. Which means the probability that she walks is 0.2. And those probabilities are exactly the same down there. So there is our completed tree diagram. Cool. Okay, then we're asked, part B, to show the probability that Kirsty walks at least one way is 0.76. So the outcomes that we want here is either she gets the bus to the shops, walks back, or she walks to the shop, gets the bus back, or she walks to the shop and walks back from the shop. So there's a clever way that we can do this. We could work out the probability of each of those paths. So we'd be going bus, walk, walk, bus, or walk, and walk. So when you work out probabilities along tree diagrams, you multiply them. So we would end up here with 3 probabilities for these 3 outcomes. We would then want to add them together. There is a quicker way though. What we could also do is work out the outcome that we don't want her to take. So that's getting the bus both ways and then take that away from 1. So that's the way we're going to do it. So the probability of getting a bus both ways, so we're going to call that probability bus, bus, that's 0.3 times 0.8, which is 0.24. So the probability that she walks at least one way, so let's call that probability that she walks at least one way is 1 minus 0.24, which does equal 0.76. Good times. Question 20. Mo's tyre pressure gauge shows a reading which is 12% higher than the actual pressure. We want to work out what the actual pressure is when the reading shows 38.64. So this is reverse percentages. If the gauge shows 12% higher than the actual pressure, then here we can say 112% is equal to 38.64. So 112% of the actual pressure is 38.64. Now we want to get down to 100%. So we're first of all going to find 1%. So to do that, we're going to divide both sides by 112. That's going to tell us 1% is 0.345, and then to get to 100% we multiply by 100. So we get 100% is 34.5. Good times. Okay, question 21, so probably quite a tricky one here. We've got a semicircle inside of a rectangle of length 120 meters. The semicircle touches the rectangle at A, B and C. We want to work out the perimeter of the shaded area. Giving our answer to 3 significant figures. So, at first, it might seem like we don't have enough information. What's the height of this rectangle? Well, if this is a semicircle, then the height of the rectangle has to be the radius of the circle, because the diameter is the length of the rectangle. So the height is 60 meters. So of the shape here, of the perimeter that we want, we've got 2 of the 3 lengths. So we've got these 2 60s. All we need to do is work out the length of this arc. So this arc would be 1/4 of the circumference of this whole circle. If it was a whole circle with a diameter of 120, then this arc, we'll call it A, is 1/4 of the circumference of this circle. So remember, circumference is pi times diameter. So the circumference of this whole circle would be 120 pi. So the arc length that we want is 1/4 of that. So 1/4 times 120 pi is 30 pi. So the perimeter that we want is 60, add 60, add 30 pi. Now if you chuck that in your calculator and we go to 3 significant figures as we want, we get 214 meters. Okay, question 22, so we got some fun with bearings here. So, A, B, C and D are towns. B is 25 kilometres east of A. C is 25 kilometres north of A. D is 45 kilometres south of A. So, this drawing is not to scale. What I'm going to do though is just put on that info. So we know that's 25. I'm not going to worry about putting kms on. That's 25. And we also know that is 45. Okay, part A wants us to work out the bearing of B from C. So, this is saying that we're at C and we want to know what bearing we would have to travel on to get to B. So what we need to remember here is bearings are measured clockwise and north is 0 degrees. So let's find the bearing of B from C. So I'm going to draw the line that joins them together, and I'm going to draw a north line in too. So it's just rough. So north is 0 degrees. So the angle that we want is this guy here. So how are we going to do this? So this triangle ABC is isosceles, and it's a right-angled triangle because C is exactly north and B is exactly east of A. So if it's isosceles, which we know it is because C and B are the same distance away from A, that makes this angle 45 degrees and this angle also 45 degrees. Now we can work out this bearing because this 45 degree angle and this angle just above it are angles on a straight line. So they add to 180. So we're going to do 180 minus 45, and that gives us 135. So our answer to part A is 135. Part B wants us to calculate the bearing of D from B. So I'm going to make another little sketch. So we want to know the bearing of D from B. So let's just make a clean little sketch. So this point down here is D. This length is 45. This length is 25. This is a right angle, and this is point B. So I'm going to move B for now. The angle that we want to find, remember north is 0 degrees, and bearings are measured clockwise. So the angle that we want is that whole angle around like that. However, that may not be the best way for us to go about finding this. We could, so we know the angle between this 25 length and the north line is a right angle. So if we can find this blue angle here, inside of the triangle, we can add that to 90 and then take that total away from 360, and that will give us this red angle, the bearing that we are after. So I'm going to make another sketch. This now becomes a question of SOHCAHTOA. So we're going to call this angle theta. So SOHCAHTOA, let's work out the two side lengths that we have. So 45 is the opposite, 25 is the adjacent. So we're using TOA, which is tan. So this tells us tan theta is the opposite divided by the adjacent. So 45 over 25. So tan theta simplifies to 9/5, which is the same as 1.8. So to work out theta, we inverse tan uh, 1.8. So on your calculator, press shift and then tan. That gives you this little tan with a -1. That's our inverse tan function. So put that in and we're going to get 60.9 blah blah blah, which I think we would be fine, just rounding to 61 degrees. So now that we know that angle, we can add that to the right angle. So 61 add 90 is 151. So the angle that we want, the red angle, is 360 minus 151. So 360 minus 151 is going to give us 209 degrees. Tricky one. Okay, question 23. So, the table shows the average number of customers per day entering a shop. So, here's our table, lovely jubbly. What you want to do is plot the points in the white part of the table on the graph. Hopefully you'll get something that looks like that. And then, for part B, we want to make two different comments comparing the number of customers in the shop in 2015 and 2016. So, one thing we could say, both years were busiest in the summer months. So that's one thing we could say. So both years were busiest in the summer months. What else could we say? There's loads of things we could say. We could say that if you add all the numbers together, we could show that 2016 was busier than 2015. Like I said, loads of things you can say with that. Okay, final question. So it's quite a big one. So each week, Dan drives 2 routes, X and Y. 1 week he drives root x 3 times and root y twice. He drives a total of 134 miles that week. We can turn that into an equation. So we can say 3x add 2y is equal to 134. Okay, then we're told another week he drives root x twice and root y 5 times, and his total distance is 203 miles. So again, we can turn that into an equation. 2x add 5y equals 203. So all of a sudden, it's become a game of simultaneous equations. So our mission here is to find the length of root x and root y. So start by calling them equation 1 and 2. What we want are two equations with the same amount of the same letter in them, so we can then get rid of that letter. So we're going to go for the x's here. So what's the first number that 3 and 2 both go into? It's 6. So we're going to multiply each equation so that we get 6x in each of them. So we're going to multiply equation 1 by 2. So that's going to give us 6x and 4y is equal to 268. And we're going to multiply equation 2 by 3. So that's going to give us 6x add 15y, and that's going to equal 609. Okay, so now we're happy because we've got two equations, 3 and 4, that both have 6x in them. So we can get rid of the 6x by subtracting one equation from the other. So we're now going to do equation 4 minus equation 3. So 6x take 6x is nothing, that's the whole point. 15y minus 4y is 11y. And 609 minus 268 is a number, 309 and 32, 341. So, if we now divide both sides by 11, we get y is equal to 31. So y is 31 miles long. Now that we know what y is, we substitute that into one of the top equations to find what x is. So I'm going to go for the top one, which tells us 3x add 2y is 134. So 3x add 2 times y is 2 times 31. So 3x add 62 is 134. Take away the 62, we get 3x is 72. Divide by 3, so x is 24. So root x is 24 miles, root y is 31 miles. And then we got this final little bit. State an assumption that has been made in answering part A. So, what we've achieved is that he has only travelled along route X and route Y, so he hasn't driven anywhere else. So we've assumed he's only driven along X and Y. If he's done any other driving along any other route or whatever, then it's going to have messed up our equations and it wouldn't be right. Right guys, that's it. That was fun. So as I said at the start, if OCR people want OCR stuff, let me know in the comments. Give us a thumbs up. Take care guys.